One of the biggest challenge is related to my work and in the field is how to map the brain with high spatial and high temporal resolution, because our brain, as what we know, it's a 3-pound matters, and so you really need to figure out where the brain is activated. And at the same time, the neural impulse is traveling inside the brain at a millisecond in the 1,000th second time scale. So you really need to figure out when and where, and that really requires a interdisciplinary collaboration, engineers, neuroscientists, and clinicians. Most of my research has been interdisciplinary and in nature. For example, like the EEG and source imaging work I have been doing is really in collaboration with neurologists and neurosurgeons. And we developed a high-resolution imaging technology to help neurosurgeons to figure out where the seizure comes from. And instead of open the skull and put invasive electrode, and they could figure out where the seizure is generating and help a more informed surgical planning. And that's just one example. Very recent example is really our work in developing a brain-computer interface system that in which we can use a non-invasive electrode and put on the scalp, and then we can read the mind of the human subject and use that signal to control a flying and model helicopter in real time in a very sophisticated task. So the ultimate goal in this technology, if we translate to clinical application, can eventually becomes, control artificial limb and a mind-controlled neuroprosthetic device. So that's really exciting to me. One is curiosity, another is really sometimes, I just feel that I want to do something to help people and also want to help lots of people. And that is one motivation that my lab, we have been focusing on non-invasive technology, because that could help a great number of the people, either disabled or even healthy people. But of course, it's curious to figure out if it's doable.
For more information about the BRAIN Initiative, visit nsf.gov/brain.